Nancy,
Can you hear me?
Chad's on. Hi, Chad. Can you hear us?
This thing makes me,
Yeah, can you hear me?
that makes me fat.
Yes. Yes, it's the camera. I agree.
All right. Today's a little more exciting, a little more applicable than security models. You guys all got through that.
Oh, you're not sharing your screen yet.
I want to show you. Show you that one.
No, you're not.
All right. Now where? Yeah?
Yep.
Okay. Class 4. You,
These are the technical difficulties.
It's Wednesday. I'm tired. You guys tired yet? So new faces. One, Michelle. Good to see you again. Have I seen you before?
I was here on Monday.
Yeah, the Packers had one.
No.
Who was the Packers guy?
That was not in front.
Oh,
He was, Packers hat guy was here.
Where's the,
He was sitting up in the.
that's Josh.
where's the Packers hat guy?
He's not here.
Oh, not toy from there. All right, let's get going. I don't remember how many slides we have. 112. What do we have last? What do we have on Monday?
Yeah, right around 100.
90? Maybe. I'm the guy that took us a half hour over last time, sorry. I'll try to go faster today. We'll stick to the content. I won't give too many stories, probably. So we got through chapters 1, 2, and 3, and partway through 4. Today we'll probably get about halfway through 4. We're going to get through some system design, architecture stuff, system, my computer system, and then we'll get to, I can't stand looking at myself on this thing.
You should be able to close it or minimize it.
I'm good.
Yeah.
What are we going to get through? That, and we'll get through encryption. Not through encryption, we'll start encryption. We'll go through the history of encryption. Anybody a history buff? You guys like history? Is that somebody talking?
Good.
All right. Yeah, the history stuff is pretty cool. So we'll get through some of that. You're usually sitting here. You're over there.
You guys are messing with that end.
I'm trying to figure out what the hell's going on. All right, let's keep going. So other updates, same stuff. We're still getting requests for the study group. So, we're starting to kind of compile those. There's not a ton to study. I mean, there's a ton to probably memorize, but, study groups will form here in a little bit. If you have questions or want to participate in the study group, there's the email address again. And then we do have a Slack channel that we just set up. So we'll be sending out invites. So who's going to do that?
Brandon will do it tomorrow when he sends out the email with the links. He'll include the link to join that Slack channel.
Yeah, and keep it nice. None of your crap. Okay? Guys gotta get more. Yeah, whatever. Just be nice. All right, here's what we've covered so far. Just a quick recap. We got through our introduction, security risk and risk management, or security and risk management, asset security. You had the fun of going through some security engineering, the evaluation models and all that stuff. That is the driest part of the entire class. So, don't worry about it too much. You'll see some exam questions, but the applicability for a lot of that is not, it's just not there. So let's get to a quiz. What type of memory is used often for CPU registers? DRAM, firmware, ROM, SRAM. A. D. A. D. SRAM. Do you remember the capacitors? Did you go through this?
Yeah, we talked about it.
Capacitors, registers, all that stuff.
Flip-flops.
Flip-flops, yep.
And not the kind you wear to the beach.
Sweet. Nope. It's good though. So it's just, you'll just have to memorize that. What did this become? ISO 17799, which used to be BS 7799. Remember that evolution, BS 7799 to 17799 to, this is almost like a trick question because the BS is what it evolved from, so it's not what it became. ISO 27000 is actually a series of standards, so it's not an actual standard. 27001 defines the information security management system in that standard. 27002 is the management techniques, and 27002 is the actual answer. Make sense? Which of the following describes the duty of the data owner? Patch systems, report suspicious activity, ensure their files are backed up, ensure data has proper security labels. So you remember the three, we went over three roles, three primary roles, owner, custodian, and user. One fits best for custodian, that's your IT people, you know, who typically patch the systems. So one you can cross off the list, or A, sorry. B, report suspicious activity. That's usually just a general user activity. So that's probably not the best one. Ensure their files are backed up or ensure data has proper security labels. Either one of those could potentially fit, right? So it's going to be which one fits best. So what do you guys think? D? Yeah, I agree. Remember labels and clearances, right? Labels, clearances, subjects, objects, how those things fit together. This control framework has 34 processes across 4 domains. That's the one that I don't like.
But this type of code, this is about as easy a game user can get.
Yeah.
Is it the
I'm sorry?
D?
This one's actually COBIT. Yep, and it's just going to be a memorization thing. COBIT is comes from the Information Systems Audit and Control Association, ISACA. They're, you know, so if you want to read about COBIT, you can. Do you have to pay for it? I can't remember if they made it pay for it.
I don't remember, so I get it free.
Yeah, I don't know. But anyway, COBIT, I wouldn't spend a lot of time studying COBIT. Knowing some of the facts about COBIT would probably be fine. I don't apply it much. ISO, NIST, CSF, remember the cybersecurity framework. NIST, SP 800-53 occasionally, you know, probably more government related. But get familiar with just kind of the standards where they might apply. ITIL I've never used for security before. And Octave I've never actually used before either. I know Octave pretty well, but I've never used it. COBIT. All right, which managerial role is responsible for the actual computers that house data, including the security of hardware and software configurations? Responsible for the actual computers that house data. Custodian, data owner, mission owner, system owner. So this one, it's not going to be data owner or mission owner. It's either going to be custodian or system owner. Custodian would do.
Isn't the key the managerial role?
Yep, that's right. Yep, so we can usually go with system owner. Right. The type of relatively expensive and fast memory uses small latches called flip-flops to store bits.
It's easy.
SRAM. What type of memory stores bits in small capacitors like small batteries? Okay. The keyword is deep dynamic. Yeah, the DRAM. Easy. I didn't ask you any security model questions because I didn't want to kill you anymore with that. All right, so now we're going to get into the rest of this. We're going to get into secure system design concepts, some hardware architecture. A+ people, hardware people, you can get really deep in hardware. I take it a little bit further than the book, but beyond that, you could spend all day just talking about, you know, the latest and greatest things that are out there. You don't need to know that for the exam. You want to know that stuff, you know, feel free. I don't spend a lot of time. I mean, I think none of us really spend a lot of time in hardware anymore. Well, maybe some of the tech services guys, we have some people that like to do embedded stuff and whatever, but we'll get through the hardware architecture architecture cover the things that you definitely need to know for the exam, go a little further. Like I said, I'll give you some reference materials. What am I doing now? What's going on here? What do I do now?
Nothing.
All right.
You're all set.
Well, yeah, but I thought I was already all set. You reached
You were
over-
using the mic off the camera.
For real?
Yeah.
That's cool. All right. Secure hardware architecture, we talked about that. Secure operating system and software architecture, so things like reference monitor, kernel, user mode, kernel mode, we'll want to talk about all that stuff. Make sure you're clear on what those things are. Virtualization and distributed computing. We'll talk a little bit about cloud. There's not going to be a lot of questions about cloud in the exam. Probably more things like infrastructure as a service, software as a service, platform as a service kind of questions, but not real deep. Virtualization, there's probably 4 things we need to remember in there. Vulnerabilities, threats, and countermeasures, we'll cover that, and then we will get into encryption too tonight. And what I say, we'll take 3 classes, yeah. So this is the second of the 3 classes. So you clicked over here now, and I'm gonna go back over here.
This is payback for making you do the security models.
If you're following along in the book, 116 should be about where we're at. All right, so layering. So layers, I grew up a network guy, so I understand networking. I understand layers, really how it applies to networks. So the OSI model, I know very well. The same concept applies with hardware, right? It's just about abstraction. It isolates functions that happen in different parts of the operating system. So you have, we'll get to rings here in a little bit, but so you have the hardware, and you've got drivers that interact with the hardware, and then you've got, so just additional layers of abstraction all the way up to the user interface, which would be kind of the thing that you interact with all the time. So like when you click something on the browser, there's a lot of things that happen inside the application and inside the operating system to make it all work, right? Including packaging data through the OSI model to get, and it's conceptual. So these things aren't like hard coded into an application necessarily, or hard coded into the operating system. It's more conceptual. The kernel in an operating system is really what controls, all of it, right? It's kind of the big dog. So for networking types, OSI that's Open System Interconnect. We're going to talk about that later. Any network people here? Yeah, so you know the OSI model probably pretty well. And I never learned the acronyms for the OSI model. I always just learned the words. So application, presentation, session, transport. Yeah, it's network, data link, physical, right? I mean, you just remember them that way. But there's some cool acronyms that we use. Is that what you call it? An acronym when I create letters?
No, mnemonic.
Mnemonic?
Yeah.
Yeah, so I'm a security guy, I am an author, wrote a book, but don't know words well. Generic list of security architecture layers: hardware, kernel, operating system, application. We'll talk about all that. This is just a good description of what I was just sort of trying to explain to you. In this case, and this might be the example, actually, it's out of the book too, about when I open up an MP3, a music file, all the things that have to happen behind the scenes that you don't ever see. Loading device drivers, packaging the data for, the electronic signals that would go through the speaker. I mean, there's a lot of things that happen. It's not just double clicking. So all that stuff is called abstraction. And that's the part that you need to remember, is the word for what's happening kind of behind the scenes. It's all abstraction. It also makes it easier to write applications, because I can write an application for a specific function and not have to know all the things that, potentially have to happen, right? So I can write to a specific specification or whatever. Good example from the book is that one. And I like complexity is the enemy of security. Have you guys heard that said before? First guy I ever heard say that was Bruce Schneier. He was giving what was it? It was an interview for a newspaper or a magazine article. And the interviewer had asked him, are we getting better at security? And his comeback was, no, we just keep making things more and more complex. And complexity is the enemy of security, which is a good thing to remember when you're building a security program, right? Or if you're considering buying more technology, you're just making your job, oftentimes harder and harder and harder. So look for simplicity and everything, which is easy for me because I'm a simple guy, right? I remember one time I was out at, where was I? We were trying to figure out their, see, I'm going into stories again. We were trying to go through their employment change process. So normally in identity management, you've got, you need to have an onboarding process, something to get into the system, right? So somebody needs to enter a new identity and set all that stuff up. And then people change roles in the organization over time. So you have to have change processes, right, to manage it sort of within the system. And then you've got, termination or offboarding, whatever you want to call it. Well, they were really struggling, and it kept becoming an audit finding this change process. And when they were explaining it to me, I was trying to write notes, and I'm like, I don't get it. We're gonna have to whiteboard this thing. So you ended up whiteboarding it, and see that big whiteboard over there? The processes almost took up that entire whiteboard, right? Where a lot of times in just an employment change process, why not just deprovision the account and reprovision the account? Right? I mean, you could kind of do it in 2 steps instead of this. It was just crazy what they were doing. So that's complexity. I don't like complexity. The ring model, this will be testable. This is conceptual. It's not, hard. It's not burned into anything. But there are 4 rings. So the ring 0 is the lowest level ring. As you get out from that, it becomes user land, which means there's a lot more abstraction from the hardware, from the actual, CPU, motherboard, whatever is being controlled. So ring 0 is where the kernel lives. It's kernel mode. Operating system components outside of ring 0 live in ring 1. Device drivers in ring 2, and then user applications in ring 3. So even within the user application itself, there's layers of abstraction before I get to the device drivers, and then there's more layers of abstraction before I get to the kernel. And there's a part of the kernel that sort of kind of plays like traffic cop and all this. It's called the reference monitor. That's what enforces the system or the security policy for the operating system itself. So reference monitor will be a word that you'll want to know. Kernel will be a word that you want to know. You'll want to know abstraction, and you want to know what these 4 layers are. And these are all applicable. These happen in all computers, so it's not like this has gone anywhere. Processes communicate between rings via system calls. System calls are slow, so you won't notice it, but they are slower than operating on the same, basically on the same ring. Yeah, abstraction, we talked about that. Linux and Windows, actually in reality only use 2 rings, ring 0 and 3. We'd call ring 0 kernel mode, and we call ring 3 user mode. Just where things are running at the time. Hypervisors, sometimes I'll call that ring -1, a hypervisor, because it's another layer of abstraction between the operating system even and hardware, depending on the type of hypervisor you're using. There's also hypervisors that are run within the operating system itself, so like, what's the Oracle one? VirtualBox, that'd be an example of that. So different types of hypervisors, but we'll get to that too. Any questions on the ring model? Pretty basic, yeah, the concept anyway. That's what it looks like. I did add a lot more graphics into these slides because, I figured you guys would use these as reference and maybe study materials as you're getting ready for the test, and you can just quickly page through this stuff. Most privileged, least privileged, yeah, good stuff. All right, so we've got open and closed systems. This is also pretty easy to understand. An open system is a system like the AT systems, the IBM compatible systems, they used to call it. They're systems that anybody can kind of make hardware for, right? It's open specs. If I want to make a new video card, I just have to make a video card that would, if it's a PCI bus, then it will fit in the slot, has the right pinouts and all that other stuff. Closed systems you can't do that, right? You either have to partner with the company in order to write something or create something for it, or be the company itself. So Apple's the classic kind of closed system. We see the same thing in mobile devices today, right? The Android devices are an open system. The Apple devices are closed system. The entire ecosystem, right? Even applications. Any questions on open and closed systems? Basic, good. All right, system unit and motherboard. These are the two things, system unit and motherboard. System unit is the entire case. I've got a picture of that. And then the motherboard is that the board attached to the case and everything plugs into that. It makes the system run. There's what a case looks like, or I guess a system unit would be everything, that entire everything. You guys built your own computers before? So you've been through this. You guys ever been to Micro Center? Yeah,
I'm not allowed anymore.
It's like a toy store. Toy store. These guys just went to Micro Center. They asked me if I could go, and I was like, I can't. My wife would. I was just there on Saturday
With your wife.
with my wife.
That's the only way
Yeah,
I'm
she
allowed
has
to go.
She,
No.
she has to come with me.
Yep, that's the same.
But then I was gonna say a bad word. She complains the whole time. You know, I'm looking at everything. She's like, "What did you come here for?" I'm like, "Well, it doesn't
I
matter."
don't know. I don't know what I need until I see it.
Right.
So I'm here.
Right.
That's why I'm not allowed to go anymore.
So if you've built a system, this is all pretty self-explanatory. If you haven't built a system, the important part here is that this entire thing is called a system unit. And the pointers, it's good stuff to know. It won't be on the exam, but it is good stuff to know just in practice, right? And then there's the motherboard. There's a lot of pointers on this slide too, because there's a lot of things that happen on our motherboard, right? The only things that we're really going to talk about is the CPU, the central processing unit. We'll talk about the buses. The buses are really communication lines between a device, usually a device, maybe memory, and the CPU. We'll talk about ROM chips. We already talked about that. You talked about ROM
Yep.
chips.
Talk North Bridge, South Bridge.
Yeah, we'll talk North Bridge, South Bridge, North Bridge fast, South Bridge slow. Because, you know, Yankees are faster than Southerners. No, I'm just kidding. That was just a jab at you.
It's like,
What the hell? No. So anyway, that's the motherboard. Computer. What's that?
Circa 06.
This one? Oh, yeah. Well, that's what I'm saying. I don't want to get into like see, I knew there was going to be people like you that are going to be like, dude, that was from like 2006. Nobody uses that anymore.
Yeah, no.
I get it. But
It's the concepts that are important.
yeah. Yeah. The Harvard guys, they always get me. So they're like, you don't know what a blah, 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 blah is? I'm like, no, I have no idea what the hell you're talking about. Yeah, but 2006. Computer bus, communication. Anytime you're bus, communication is just a communication line. Communication between CPU, memory, communication between anything in the CPU is going to have to travel on a bus, some sort. These are our computer buses, basic computer buses. You know, North Bridge, South Bridge, like we were saying. North Bridge is faster. Memory connects into the North Bridge. It's a fast route into the CPU. South Bridge is typically slower, more I/O devices, things like that. Yeah.
They will ask about that too.
North Bridge, South Bridge.
Yep.
All right.
Just put at that level, right? The memory connects to.
The videos also, you can see there.
Yeah.
Through North Bridge, typically. But then, you know, bless you. So North Bridge, also called the memory controller hub. South Bridge, also called the I/O controller hub. That's just what they do.
Yeah, that's what you need to know.
You all need to know that?
That level.
Yeah, you don't need to go much deeper than this. If you want to, and you're already a Harvard guy then, or gal, you're way ahead. But sometimes you overthink stuff, right? I mean, you oversee I do that in other security things where I just kind of float over it and miss a basic, you know, so be careful with that, even if you are, you know, good at hardware. So the CPU, the brains, everything goes through the CPU. Two big things. The CPU is the ALU and the controller unit. We'll get to it in a minute. But the ALU is the arithmetic logic. I can never say arithmetic, but that's where the actual calculations happen. We'll go through that. 2.4 billion clock cycles per second. If you have a 2.4 gigahertz, that's what gigahertz is. It's how many clock cycles. There's 4 steps in a clock cycle. Yeah, that's what the CPU does. There's some CPUs.
Got an i7.
Yeah, it's not like 2006 anymore, is it? When was I7 come out? That was probably 2000.
There's many generations.
I know, right? And that just makes it even more confusing. I could follow the numbers, but then we had some numbers dot numbers and then names for the numbers dot numbers.
Yeah, I-7 came out in about 08.
Oh, yeah.
Quarter four, socket 1356.
What's that?
1356, quarter four of 2008.
See, another hardware guy. You guys scare me a little bit. Just a little bit. Because you guys know so much about hardware. What's the latest processor? Like Gen 9?
Gen
Who said
9 is more of the current one on the Intel side, and then AMD is the Ryzen 27 series.
We're threaded.
The 2000s are up to 3.
Kyle, are you a hardware guy too?
I gotta build,
No, you're supposed to. You're a
I
tech
gotta build
services guy.
computers to play video games.
Oh, yeah. So I can't play, I have a very addictive personality, so I can't play video games anymore either. I get banned from a lot of things. Okay, so anyway, there's just pictures of your CPU and, they attach to the motherboard. There's our 4 steps in the cycle. We've got the ALU and the controller unit. The controller unit's the traffic cop, what comes and goes essentially from buses to the CPU. Also controls timing. ALU is where, like I said, the logic happens. That's where we actually, do things. There's 4 stages in the cycle there. I like this graphic a little bit because it kind of showed where things happen a little bit more. But there's those 4 steps of the cycle. So fetch, decode, execute, store. Fetch, decode. So imagine that 2.4 billion times per second.
And they do as kind of at that level, they'll say, what does this? And have those, and you'll need to know it's a CPU.
Mm-hmm. Yeah. Any hardware developers? You guys write any? No. All right. Pipelining. So pipelining is, if I don't do pipelining, I have to wait for instructions to finish before I can start the next instruction. Pipelining allows me to start. So as soon as, if I go back here, as soon as, one instruction is gone through the fetch and then moves into the decode, another can start the fetch. And then when that first one goes into execute and the second one went to decode, then the third one can go to fetch, you see, or the first, so that's pipelining. Otherwise you have to wait for the whole cycle to go. So CPUs do pipelining. There's another view, a linear view of what I just said. So without pipelining on the top, you have to wait for the whole instruction to complete, the whole cycle to complete before you start another cycle. Whereas, pipelining is doing them in parallel almost. Were you gonna say something?
No, I'm just having like PTSD ticks.
Yeah, you looked like you were kind of.
Oh, I haven't thought of this since I took the.
Yeah. Interrupts. So interrupt is just like, this one's pretty self-explanatory. There's a call, there's an interrupt. So there's a request from the CPU to do something. When the CPU is operating on other things, that would just be an interrupt. A lot of times these come from IO devices. So they're usually hardware related of some sort. But if you have, it's just part of how computing operates. You can't not have interrupts because you're all using hardware, right? As soon as I moved my mouse, I created interrupts, because the CPU was working on something else. There's just a view of interrupts, and you don't need to know that, but it helps maybe to have it just sink in on what an interrupt is actually doing. Other things, process, thread, you got heavyweight processes, lightweight processes. A heavyweight process is called a task. Processes spawn additional processes. A process that's been abandoned, meaning its heavyweight process or task is stopped, but you still have a process that was spawned by that heavyweight process. The heavyweight process has been terminated, but the thread is still going. That's a zombie. That's the one over here on the right, or orphan, some people call it. This is how things get to the processor, to the CPU. Process states: new, ready, running, blocked, terminate. They all share memory, or they don't necessarily have to share memory. We have, there are memory protection, mechanisms built in, and we'll talk about some of those things. But it's a much faster way to run applications, a multi-threaded application. because they can share memory, right? You don't have to go through all the addressing. So anyway, heavyweight processes, lightweight processes, good stuff. Any developers here? No? All right. Good. Because developers are security's enemy. No, I'm just kidding. I don't know. I grew up, one of the companies I used to work for was Jask Software. You guys ever heard of PaintShop Pro? Way back in the day. This is like,
It's pre-2006.
yeah, it's pre.com.
I remember it.
Yeah. Shoot, I forgot what I was gonna say. Oh, yeah. So we made PaintShop Pro, so everything was about the developers, and we had like prima donna developers. Hopefully there's not any older ones, still here, but man, we had to cater them all the time. I mean, because they ran the whole shop, right? So it didn't matter what security said. And back then we didn't really call it security. We got a lot of stories about the first time I was hacked. We used to put our downloads would get about 3 million downloads a month. And so we had to have distributed downloads. We had at the time we had what were we running for bandwidth? We had a DS3. Anyway, so we'd colo, right? You'd find somebody, hey, do you have an internet connection? That's basically what it was. Do you have an internet connection? Okay, can I put a server there? And you wouldn't put a firewall in front of it, and so these servers would get tipped all the time. They ended up being just honey pots. But the cool thing is the attackers they weren't in it for the money. They were in it for because storage was really expensive back then. So they were looking for places to store their wares, right? So, MP3s and movies that they had stolen. So we didn't necessarily even get upset when they tipped a box, because we just like rebuild it and, oh, cool, new movies, But yeah, those were back in the days. And that's probably not, does that make me a gray hat? Being I was doing that? Probably, right? Crap. I thought it was much better than I was. CPU multitasking, so anytime you hear the word task, it's going to be a heavyweight process. If you hear threads, it's going to be a lightweight process. So multitasking allows multiple tasks to be running at the same time or sharing the same CPU, not necessarily running at the same time, because in reality, they don't run at the same time. The applications are running simultaneously. Those are multitasking. Multiprocessing means multiple processors, right? Now there's either symmetric multiprocessors or asymmetric multiprocessors, and it comes down to how many operating systems are running on what CPU, right? So in a symmetric multiprocessing, one operating system to manage all the CPUs, asymmetric, one operating system per CPU. So those would be multiprocessing systems. Multi-programming systems, everything's a multi-programming system, allowing multiple programs to run at the same time with the CPU. And then multi-threading, just multiple lightweight processes. You'll need to know these things for the exam. Most of you probably already do know these things, so it shouldn't be too difficult. Watchdog timers. Watchdog timers are used to recover the system after there's a real fatal error. So that's what they're used for. Something hangs, something crashes. If you didn't have a watchdog timer, it might still be residual, and you may not reboot. So that's its function. There's two types of computers mentioned here. There's the complex instruction set computers, which is the ones that we're all using. And there's reduced instruction set computers, which are built for specific functions, right? So they're typically much faster. They're optimized for whatever specific functions they're supposed to run. But they also take a lot less power because they're only doing specific functions. So RISC-based computers, they're just built for a specific purpose. That's really the difference between a complex and a reduced instruction set computer. Addressing modes are CPU dependent. There's really direct and indirect. It's just a question of whether you're talking about main memory or you're talking about registers. Remember, registers are on the CPU itself. So direct addressing means, give me something at 1, and it's actually at 1. Indirect addressing would say, give me something at 1, and 1 is actually a pointer to 3. Right? That would be indirect addressing. Both, they're CPU dependent, but you can have both on the same CPU, direct and indirect addressing. Register direct and indirect is the same thing. It just has to do with the register and not main memory. Make sense? Yeah, and there's an example, direct and indirect. So one's just a pointer to the other. Indirect makes sense. I'm going to give you an extra slide. All right, so memory protection, the best memory protection is complete isolation. You know, that's the best protection really in anything with security is complete isolation. Isolation of the network, isolation of system components, isolation of memory, but it's also more expensive, right? And it's hard to justify that sometimes. So hardware segmentation would be completely separate hardware. That's one way you could protect your memory. It's really hard for a thread to jump from one computer over to another computer to steal memory, right? Even if you were, there'd have to be some connectivity and you'd miss your race condition, right? Usually it's a race condition. Race condition is, sometimes it's called TOC, TOU, time of check, time of use. So it's when I send something to the computer and before the computer gets a chance to answer back, I slide in another thread or process, the malicious one. So that's a time of check, time. We call that a race condition. That would be hardware segmentation basically eliminates that because you can't get it fast enough. Does that make sense? Sort of. We'll talk more about that as an attack later. Virtual memory is another way that, you know, there is some memory protection because now the kernel is involved in virtual memory. So, you know, it's not just the CPU. I also have to get by the reference monitor in the kernel. So yeah, memory protection. Swapping and paging, use the virtual memory. Virtual memory, usually disk, right? And you can, if you've had an application, you know, usually a poorly written application that thrashes, you know, it's just your disk is going crazy. And then your fan goes on because your CPU is running super hot. You know, a lot of times it's swapping and paging. But you have swap files. We used to have to set our swap files manually.
Mm-hmm.
Now, you know, I don't, can you still do it?
Yeah.
Or is it all just automatic now? Can you set your swap file automatically?
Okay.
Yeah.
You can, okay. Yeah, you had to before. All right, and you can move swap files to other disks, whatever. BIOS, basic input output system. You know, you see it when you do a post, right? When your system turns on and either you've got a fast post, slow post, whatever, but there's a BIOS that loads somewhere in there. The first thing that will run in the BIOS is the post, then it'll look for the boot sector. And in the BIOS itself, it'll have what disk it's supposed to go to. So it'll be looking for the boot sector in that disk. And where the boot sector is a pointer to the kernel. And then the kernel loads for the operating system and things, you know, come up. So contains code and firmware executed when the PC is powered on. The first thing is to run the post. That's checking to see that it's got all the components that it's expecting to have in the system. It's got the memory. If you've got TPM, it'll be looking for something there. Then it looks for the boot sector, loads the kernel, piece of cake. You've all been in, not all, but most of you, I assume, been in BIOSes before. It's essentially the same thing that I just mentioned, just in a different graphic, whatever graphic seems to fit best for you. First sector, yeah, the first 512 bytes in most drives, or most, I don't even know if that's true anymore, actually, because I don't know much about a lot of the newer SSD stuff, but in the magnetic drives, it was always the MBR would look for the kernel in the first 512 bytes of the first sector of the drive. So I don't know if that's going to be on the test or not, or if it's just kind of FYI stuff. Any questions on any of this? You guys actually, I'm having trouble reading you. So I don't know whose identity this steals. Probably, well, you're not the Packer guy, are you? If the Packer guy was here, it'd be his. He's probably on.
Nobody's taking ownership of that.
Nobody's taking on the Packer guy. So this stuff is either like really basic for you, or you have no idea what the hell I'm talking about. And I don't know which of you is feeling what right now.
So,
you two are like whatever, because you said a bunch of stuff I don't even understand what you said. And you're a gamer, so you do all that stuff. But are there any questions on any of this stuff? Because it will be all exam-y. Okay.
So asking online if UEFI and TPM are going to be covered.
TPM will. UEFI probably not.
Still too new.
Yeah. But TPM,
Multiple people are
TPM
asking.
will be. So write only, read many. This is usually where you store archives, right? You write them and then you just access them on a regular basis, but you never really overwrite them. These used to be super popular in like law firms and libraries. They would store a lot of files in these, and it'd just be an array of really like DVDs. Write it once and that was it. Not the worm bin. I tried to insert some humor there, but you guys are all probably like whatever. So, DVDs. So DVDs, CDs are worm, not DVD-Rs and CD or CDRs, right? I haven't seen a DVD-R drive. I mean, I haven't used a DVD-R drive in like the longest time. It's crazy. Have you? 2006? Yeah, basically. Because now they don't even sell systems, really. None of the laptops come with them anymore.
Yeah.
Actually, I was doing an investigation for a, they're probably online. Yeah, forget about it. I was doing an investigation. They sent me
Oh, yeah.
They sent me a DVD drive instead of the hard drive. Yeah, so it's hard to do an investigation on the DVD drive. TPM, so TPM Trusted Platform Module is, I'll show you a picture of it. It's just a module that sits on the motherboard, plugs into the motherboard. You can do it either way. And it's there to enforce the integrity, really, of the system. So with a TPM, allegedly you can't bypass the boot sequence, right? There's a pre-boot authentication built into the TPM module itself. But also with the TPM module, I can offload some encryption, functions. So it can encrypt my hard drive faster than non-TPM. Hardware is always faster than software. So if you can offload something into hardware, especially something like encryption, that's so math intense. Encryption's, CPU intense because it's math intense. So TPM is good for all of that stuff. It is an international standard, usually on the motherboard, hardware-based encryption, fast boot integrity. So making sure nothing inserts itself. You guys have all cracked boots, cracked the boot sequence before. Some of you maybe. You can do something as simple as booting to a CD drive to bypass, the login. So that's why pre-boot authentication is really important. We don't like non-pre-boot authentication. So because we get that a lot. Oh, your hard drive's encrypted, but they don't. I've seen like 3 in the last 6 months where they have hard drive encryption, but no pre-boot authentication. So there's no integrity to protect the boot. It's like, well, what the hell?
Right. Yeah.
Yeah.
Yeah, we were on that one.
Yeah.
We have all laptops. Do we need pre-boot authentication? Yes.
Mm-hmm. Yeah. Well, authentication, encryption is so cheap now anyway, and they've got, so many of these applications are what, 3-4% processor overhead, maybe? And so to not encrypt now, really desktops too, just encrypt everything, in terms of things that could potentially easily be moved. TPM chip, that was a TPM chip, that little thing sticking up, that's your TPM chip. Tidbit, yeah, it's not testable, but it's just some things about the DoD and STIGs and, what TPM version they permit, but that's probably outdated too now. Data execution prevention and address space layout randomization. These are things that we would do to try to foil an attacker, I guess, because if things become predictable in a system, you can get ahead of it, right? If you know what the next instruction is going to be and where it's going to address memory, you could potentially be there by the time it gets there, right? Or at least be ready for that time of check, time of use attack, that sort of thing. So intentionally corrupting the memory, buffer overflow attacks. Buffer overflow, if it could be a reference monitor problem too, a kernel, but usually it's an application, the way the application was written, or certain memory space was allocated to this application, and you overwrite it, right? You force more into the memory space so it spills over in another space where you have actual execution. Your code is running. So we don't like that, obviously, but within hardware or software, you can just change memory locations without, so the attacker doesn't know where it's going to spill over, essentially. Make sense? We'll talk more about buffer overflows later. We don't need to go too much into it right now. That's what a buffer overflow looks like. If you do want to read about buffer overflows, there's a pretty good 12, 13 slide overview of what buffer overflows do and what they look like. Are you doing OSCP now? No.
Do this first.
Are you doing this first and then, okay, yeah, so you'll get to know buffer overflows really well.
I already do because
Mike and Matt do it, yeah. How common would you say you run into?
Oh, I don't do pencils,
But them, do you have any idea?
it's not too often. I know it's big for the OSCP because there's a guaranteed box.
There's a guaranteed, yeah. Well, a lot of times developers too can do really good bounds checking, in their application itself, so you can't bounce. Usually it's sloppy code, beta stuff. Kernel, so two types of kernel, monolithic kernel, and the monolithic kernel is a kernel that has to be recompiled every time you make a change. Every time you add new hardware, you recompile the kernel. Every time you add a new function, operating system function, you have to recompile the kernel. And then you've got microkernels. Those are our Windows kernels where they're modular. You can continue to kind of add things without having to recompile all the time. That's the difference between those two types of kernels. The kernel really is the interface. So if the kernel is insecure, the whole system's insecure. I mean, it enforces everything essentially on the system within the operating system. Everything has a tie into the kernel. There's the reference monitor. The reference monitor is also part of the kernel. So it's in the middle, right? So you've got subjects, objects, everything is going through the reference monitor. It's what's making the decisions. The policy, the system policy is there. Sometimes, what we were using before for policy was the written policy. This is a system policy. It's something that's written into the, configurable, right? But that's what that is. Authorization database. So an Active Directory, that would be Active Directory, right? That would be the objects. That would be what it would interrogate in terms of this conceptual drawing. Then the audit trail. There's our IAAA, right? There's that last part, the accounting. Reference monitor does all of that. Make sense? File permissions, basic stuff. If you've been in Linux, you know how Linux file permissions work. But you've essentially got world, group, and owner permissions, and you're going to see 3 series of numbers, and it's going to tell you what permissions each has. Yeah, that's Linux, Unix. That's an ls-l a. This is NTFS permissions, read, write. You've seen these before, right? So all of you have, I assume. Okay. Pretty basic stuff, but reference monitor would enforce that. So whatever you put in here, the reference monitor enforces it, right? So you're making modifications to the policy, the system policy, and the reference monitor. That's all it is. Virtualization, so transparent full virtualization and para-virtualization. Those are the 2 types of virtualization you'll need to know. Para-virtualization means that the operating system has been modified in some way to run virtualization, to run multiple. And then the transparent is just a stock operating system. Makes changes as necessary. Those are the 2 types of virtualization. You guys know what virtualization is, hypervisor, right? Okay. Do you have any questions online?
I was just looking it up, but I'll ask you.
So I'd like more questions.
Linux
Makes it more fun
permissions.
rather than just standing up here talking to you guys.
Linux permissions in the exam is going to be like RWX, or will it be the numerical representation? And I don't remember seeing that, and I was looking at my notes to see if I had.
I'd learned them both.
Yeah.
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 Yeah. So
I don't remember.
about this.
Yeah.
Yeah, that's the traditional.
I think you would have to know both, but I was gonna look and see if I had any
Did you get
notes
the
around it.
question? Whether you have to know RWX or you need to know the numerical representations, which is what, 731? I haven't used it for a while.
I don't know.
Do you guys know? Hello? Nope.
Depends
Thought
on
we
what you
were-
want to say.
Thought we were buddies.
Well, it's binary, so
Right.
it's whatever combinations of the three.
Right, that's why it's
I mean,
7.
it'll accept either.
Right.
But choose permissions.
And they're trying to wonder if they need to memorize.
I mean, the book only has the new letters. So.
They only have the letters. Yeah. So go with the letters.
Yeah.
Find out, but know them both. Yeah, there's our virtualization, hypervisor, type 1 and type 2. So type 1 is part of the operating system itself. ESX is the, kind of the classic. And then type 2 would be like the, hello, Oracle, VirtualBox would be, yep, a type 2. Microsoft, do they still have one?
The Hyper-V
Hyper-V?
can be either or.
Yeah, those will all be type 2. That's what they look like conceptually, between type 1 and type 2. Benefits, obviously, the benefits are the lower cost. We used to have blades, used to be before we went virtual. Do you guys remember blade servers? Yeah. Ran so damn hot. You had the cowling on top and.
You know what's not a good redundancy model? Is multiple blades in a single chassis.
No, well, IBM would let you, what, 13? What's that?
No, I know Brett's talking about it, always reference, and I was just saying, I've never seen that.
No. How many could you run in one IBM chassis? You could run like 13 blade servers.
You can run like
that?
12 or.
Yeah, they're usually 12, 13, 14, somewhere in that range.
And it would run hot.
Oh, yeah.
But it saves so much space, and you had multiple blades.
And didn't
So if
save,
you-
it
if
didn't
one
really save on-
failed-
it didn't really save on power much
No.
either.
Yeah, that ripped one out. That's good.
Yeah. But that was prior to, I mean, that's kind of where things went, right? You'd have, you remember the big 8U?
Yep.
P2400s? That's back when I used to be a system admin. So it kind of shows you my age. Then I went to blade servers and then blade servers to virtualization. But lower hardware cost, lower power cost, smaller footprint for sure. Security issues, it is more complex. Anytime you add more stuff, it makes it more complex, which makes it theoretically harder to secure. I don't know of any hypervisor successful attacks. I know of some theoretical attacks on hypervisors, but nothing that's actually.
There were a few where you could break out from like ESXi was.
Yes.
Amazon patched it a few years ago.
Okay.
Had issues where I don't know if that actually happened, but it was like, hey,
Theoretical.
we found this, we can break out in root access.
Yeah, because I've never seen one actually done, before, but theoretically you can do it, and I've read papers of how. But so that's one of the concerns. But even then, it does make sense to not put systems of different sensitivity on the same physical system through the same hypervisor, because you never know, right? So having those on separate physical boxes is a good idea. Yeah, because theoretically you could, if you could compromise the hypervisor, you could compromise everything on the hypervisor just because of where it sits, in those layers. Cloud computing, man, they come up with a new buzzword for something in cloud computing, like I don't know. These are the ones you need to know. So infrastructure as a service, where essentially you get the infrastructure, you get a server, you get a box, you can put stuff on it, whatever you want. Linux server hosting, something like that. Platform as a service, where maybe you've got a platform where you can install your own applications, configure your own applications. Web hosting services are the most common for that. And then software as a service would be like, what's the one that just got profitable finally? Salesforce?
Salesforce, yeah.
Yeah, how many years is that? They just
lot.
turned their first profit. It was like, I don't know what percent it was, but it was like a really small profit. Software as a service, because everybody rushed. I mean, it still is a huge money grab. Yeah, now Microsoft came up with like 4 more, and I don't even know what they are.
So
When the cloud became a thing, you know, a networking guy, because I grew up a networking guy, I'm not so much a server, you know, a hardware guy. They would show us architectures of these, hey man, new cloud, and you look at it and be like, it's a network. I mean, it's the same, we've been doing this since like.
yeah, it's somebody else's computer.
Right, but we were always using other people's computers too, you know, so it was just like, but, you know, it became this big thing, made lots of money. Marcus Ranum, you ever heard of Marcus Ranum? He's one of the kind of pioneers in security. He's probably retired now, but he did a video on cloud computing. It's really funny. So if you do like Marcus Ranum, if you Google Marcus Ranum, R-A-N-U-M, and cloud computing, watch that video. It's kind of funny.
Tell Brandon to find that and send it out.
Yeah, it's a funny video where he's talking about your bits getting wet and stuff like that. You were gonna say something?
Ranum?
Marcus Ranum, M-A-R-C-U-S, R-A-N-U-M.
So you'll need to know how to differentiate between this, and they'll give you a scenario that says, you know, these are your responsibilities for this, or here's what's included. What type of service is it? So, right, if it's infrastructure, you're responsible for everything. If it's a software, you're not responsible for patching the back end, all that stuff. So just understand kind of at a high level how to tell these different service offerings from each other.
Yep. Private cloud, public cloud, that's pretty self-explanatory. One, I could set up my own cloud, which then I'm not using other people's stuff. So it's like truly like a network. So private cloud, public cloud would be, you know, I don't control it, I don't own it. Biggest cloud provider in the world today is Amazon. Still by a pretty hefty margin. You know, Microsoft and Google are probably close behind.
It's not that close.
No, I mean, they're close, that's what I meant. They're not close to Amazon, but yeah. Yeah, Amazon, man, it's crazy how
It's so cheap.
So there's software as a service, platform as a service, infrastructure as a service. So, you know, it's just complexity, you know, additional layers going back to the abstraction thing. Infrastructure as a service is really the lowest level. And then you get platform as a service and get software as a service. Security issues need strict SLA. So there's a whole bunch of things. Cloud Security Alliance is FedRAMP. You know, FedRAMP is a certification for cloud service providers. If you're going to do business with the federal government, provide them a cloud service, you'll probably need to get FedRAMP certified. Yeah, I wouldn't want to do it. And we never got into that business just because I don't like getting into stuff that we don't like to do.
We did a call with somebody and they used a very large, well-known national company that will do the FedRAMP stuff. They said it's 18 to 24 months on average cost of $1.5 million.
No thanks.
But then you're locked in with,
Right.
You have a government sponsor, you're going to get 10-year contracts out of it.
True.
But you have to have a sponsor first.
Yeah, so
It's not worth
FedRAMP,
it.
I don't think FedRAMP will be in the test.
No.
But that's one that we run into a lot. CSA has their own CAIQ. I can't remember what it stands for. Cloud Assessment something Q.
Shoot. Yeah.
It's a good assessment for cloud service providers. You know, it's not quite so onerous. Is that the right word? So if you are doing cloud services and you want the biggest issue is cloud access, right? So CASB devices, you're a CASB, Cloud Access Security Broker, CASB, because people sign up for stuff all the time, right? Like a new Dropbox account. Where did this come from? You know? So CASB helps you.
It's Consensus Assessment Initiative Questionnaire.
That's the CAIQ.
There you go. You don't need to know, but.
Yeah, but if you're interested in cloud stuff, those are good places to go for cloud security things. Limited visibility, that's probably my biggest concern is, you know, I don't know what I don't know. You know, because I know I can't prevent all bad things from happening, so it means I better be able to detect it and then respond to it. The detection and response issues I lose a lot of visibility, with that in the cloud. Cloud providers have gotten a lot better at providing you more insight into those things, so it's not like it used to be, but it used to be a pretty big concern. I actually like cloud for the most part from a security perspective because, we talked about administrative, physical, and technical controls. Well, the physical is sort of taken care of, right? I mean, building your own data center, that's expensive. So, use Amazon's data center or wherever they're hosting stuff. But the visibility thing becomes more of an issue too now when we're starting to talk more granular privacy issues like GDPR. Like GDPR, you need to know where all your data is going. And I think where they're going to end up taking that is actually where it is physically. A lot of times in the cloud, you don't know that for sure. So limited visibility is still an issue, just not in a different way than it used to be. Shared infrastructure, shared target. I figure if you can take down Microsoft, you can have my email. It's.
Well, that's the trade-off, right? You're giving up some, but they're going to put far more resources into it to protecting it than we could.
You guys ever run an Exchange server before? Yeah, I mean, it's work, right? It's work. You got to patch it, you got to maintain it. I mean, it's, especially if you have a large, right? Yeah, you don't have to patch it. That's true, but you should probably. So, offloading that to Microsoft for, I don't know what the cost is nowadays. It's $10 a user or something.
10 or 20 bucks.
So right to audit, right to assess, depending on who your cloud provider is, you might be able to get that written into the contract. And actually right to audit, and I like in every third party contract. It doesn't even have to be a cloud provider. Anybody who's doing anything for me, the right to audit is a nice thing to have in the contract. Right to pen test, maybe, but it's there. You could ask for it. A lot of them won't give it to you.
Amazon lets you.
I wouldn't let you pen test my network. I'll pen test if.
Amazon just changed some of that allowance now.
What's that?
Going through, they allow us to.
Oh, yeah.
vulnerability stuff
Like
without
Amazon,
going
but I'm
through
talking like if I'm like another cloud provider, like not one of the big ones, because we
Provide an independent.
Because we have a software as a service, right? We have, Security Studio. It's in Azure, so they're moving it probably to Amazon. So yeah, you could pen test that, I suppose. There, no?
We do.
Yeah.
But we don't want other people to do it.
And then physical boundaries, right?
It's not really a test, but
Right. Physical boundaries, that's also an issue with cloud computing. BOINC, you guys ever heard of BOINC? Grid computing, so you can make your, participate in a grid computing environment and do all kinds of really cool stuff. I can't even fathom how fast that is. Yeah, it's fast. A lot of flops. What is it? F flops? You don't need to memorize that. It's just like kind of like cool. So 10, I don't even know what the hell that number is. It's just really big. You need a computer to figure out how big that number is, to figure out how fast it is. But it's public. I mean, anybody can go out there and participate. And this isn't the only. There's lots of different grid computing platforms. SETI?
I do SETI at home.
You do SETI at home? Yeah, so SETI, when you participate, look for, what are they? They're
Radio
aliens.
signals, yeah.
Radio
signals.
Yeah. Peer-to-peer, I don't see peer-to-peer nearly as much as we used to, but peer-to-peer is it still happens. Now peer-to-peer networks are usually built into messaging apps and things like that. So like, there's nothing to stop me from sending, there is something, but through like even, what's the Microsoft one? It's not Link anymore. What is it? Skype. Right.
for business.
Transfer files that way, so it's still sort of a peer-to-peer. But it used to be a lot worse. We used to have, Napster, BitTorrent all over the place. BitTorrent, people still use BitTorrent. Napster died. Is it even a thing anymore?
It might be, but
somebody sitting out here should be looking at this stuff and be like, yeah, Napster's still a thing. Let's go download it.
I think they lost a lawsuit, so somebody owns the name, but it's not Napster that we remember it as.
And Nutella, that's not the Nutella that, you go buy in the store. It was actually a peer-to-peer app. Yeah, we had a lot of issues with peer-to-peer because there was a lot of copyright infringement stuff, a lot of just things. And, why pay for software and I could just go grab one from somebody else? There's a lot of that stuff happening, which then, depending on where it happens, could put your company at risk. You could be liable for allowing that traffic. But it's not as big of an issue anymore. It's things like Dropbox, that data leakage is more of an issue truly than peer-to-peer stuff. Thin clients, diskless workstations, you gotta be careful the way you say that. Thin client applications, seriously, every time I say that.
Enunciate clearly.
Diskless workstations. Yeah, so thin clients, it's funny how, if you've been around long enough, you saw how when we started, everything was centralized, right? You had a mainframe and everybody connected with the terminal to the
Green
mainframe.
screen.
Yep. And then boom, everything exploded, right? And it started sort of with Novell with their file and print, and then Microsoft had to get in on that game, and it was wild. And so everything got distributed, right? Everybody had to have a server everywhere, right? And then now things are sort of starting to collapse back down a little bit, or at least consolidate somewhere. Maybe it's consolidating in the cloud or just consolidation. So thin clients, large, powerful central server, everybody connects to it. Very limited functionality, not necessarily a full CPU, which you run all your applications from the server. Diskless workstations, there isn't even a disk in it, right? So it's going to boot from the network. It's going to basically do a reverse ARP, address resolution protocol. It's going to say, hey, here's my MAC address. Anybody got an IP address for me? There'll be a ARP server or DHCP, either way, that'll say, hey, I got your IP address. Take this one, and then the communications start. So no disk, boots from the network. You do have, the functionality is so limited. But everything downloads then from a central server and then runs from there, or it can run directly from that. But the key point is there's no disk in there. Thin client applications, typically these are web applications, or Citrix runs a lot of thin client applications, but it all runs on the PC. It's just that what you're interfacing with the application somewhere else. IoT, you probably won't see a ton of IoT, but on the test, but IoT is everywhere, and it's.
The S is for security.
What's that?
The S in IoT is for security.
Yeah. Yeah. No, yeah. I don't know what to think about IoT now anymore. I mean, I used to think we actually had a chance in this game, but I still do, but my God. Stop making new stuff and connecting it to stuff and not understanding what the stuff does.
Right now, it's race to market, get market share, worry about how we're going to patch and manage this
Is
stuff
anybody
later.
else concerned about having to patch airplanes, patch cars, patch defibrillators, patch pacemakers? It doesn't concern anybody?
And then sell the patch.
I mean, because we're doing so good at patching our workstations, right? So I think we're going to be able to patch
Well, it's like,
this thing that controls my heart.
I got a buddy that's got one of those.
Yeah.
Threatened to hack his heart.
You threatened to hack his heart? Well, you probably could, right? Because a lot of those telemetry protocols aren't using any authentication.
mhm.
Anyway, IoTs.
My wife's mad at me because I won't let her get the internet connected, like washer and dryer or dishwasher.
Oh,
Like,
she's
remember
mad at
that
you?
from
Oh, yeah.
the podcast? Why not? What are you gonna? The laundry's done, okay? Like you're at work. What? Yeah.
I don't get it, man.
Anyway,
Like I remember the days when, I'm not that old either. I'm only 48. But I remember the days when I had to get up and turn the knob on the television, right? And then it got to remote control and I was like, oh, that's cool. And now that's not even good enough, right? Now it's got to be voice activated. And, oh, God.
Hard pass all of it.
Oh, yeah, big time. Well, at home is the only place I get away from this, So my network is so simple at home. There's no IoT. TV, but that's so, it's cut off. You can't buy a TV anymore without.
I don't connect the TV to the network.
Yeah, because I was trying to buy a TV last like Thanksgiving, last holiday season. I was like, every single one of these freaking TVs has a
Yep.
browser. I don't want it to be
It
connected to
has
the
all the
internet.
apps on it. Nope, I don't connect any of mine to the.
We can't even buy them anymore without that.
Mm-mm.
All right, so it is a security nightmare because a lot of these devices are getting, rushed to market. Security features are an afterthought, if a thought at all. A lot of these devices don't have any ability, no admin interface to, update software. So whatever was coded is what's going to be running. And if you know anything about software development, human beings, you could write 3 lines of code and there's going to be an error. Right? Somebody missed a comma, somebody missed a
We
semicolon.
talk about that later.
I mean, it's just like, my God. So if you're going to put IoT, know its capabilities, get one that you can patch, get one that you can secure, get something. And now, I mean, if you're running them at home, run it on an isolated network segment, isolated from from everything else. And then do that with your guests too, right? So, but how many people do you think run 3 networks at home? Yeah, some of us, but like your friends,
Only
are any
3?
of them doing it? No, I only run 3. I don't, like I said, I have a simple network. I don't have anything.
My kids' iPads that are throttled,
Oh, yeah.
time limits,
We don't have to put them on a separate network to throttle them.
web filtering for them. No, oh, yes, I do.
Oh, different kind of throttling. Okay, forget about it.
Web filtering, throttling, yeah. No.
Yeah. No, yeah.
My internal one. I do have the one IoT device.
Yeah.
And then like the games and stuff are on their own. And then guest.
Right. So some of us do it, but
Some in
the wide majority, vast majority don't. So anyway, IoT's just, I don't know where all that's going to end up. Probably world destruction, I'm guessing.
That's where the DDoS attacks are coming through.
Try to progress in your career as quickly as you possibly can, amass as much money as you possibly can. You probably don't want to put it, I don't know what the hell you do with money anymore.
Under the mattress.
Yeah.
But yeah, but
Smart thing.
what's that? Yeah, go get yourself someplace in the Caribbean and just chill. You can watch the mushroom clouds from there. Is that too dark? Whatever. Everybody's going to be depressed. Nobody's coming back again. Yeah, it's Wednesday. All right, emanations. So emanations are, electronic signals that emanate from devices. From a practical standpoint, from a security standpoint, in a super highly secure environment, maybe I would care about this, but in 99.999% of all environments, I don't really worry about emanations because there's so many different easier ways to attack most targets. But you will see it. You might see it on the test. Tempest was developed by the NSA. Big parts of Tempest are still classified, so you don't know exactly how it works. But NSA, I would expect NSA to care about emanations. I wouldn't expect, the doggy daycare at the corner here to care about emanations. You know what I'm saying? So there's just are easier ways to get to things. Backdoors and maintenance hooks. They're really close to being the same thing. A backdoor is usually malicious. An attacker planted the backdoor, right? Whereas a maintenance hook is usually an oversight. The developer had a maintenance hook, in the application so that they didn't have to keep logging in every time they wanted to test something. Log in. This will put a maintenance hook in and run whatever tests and functions they want to do, and then they're supposed to remove, the maintenance hook, and then it goes into QA and whatever. There have been times when maintenance hooks have been left in, but usually those are innocent. And I told you about the typical attack sequence where the backdoor sort of fits in. Attackers, find the vulnerability, compromise the vulnerability, elevate your privileges. At that point, you're either going to plant the backdoor or you're going to pivot. Kind of depends on timing, right? If an attacker wants to come back, they'll plant the backdoor, erase their logs, delete their logs, and then come back later. And it's that backdoor channel that most people don't do a very good job at egress filtering. Egress filtering meaning traffic going out of the network. We focus so much on the traffic that comes into the network. And so if I see, this weird looking 8080 or some high port number you won't even know because you're not watching for it. But yeah, I mean, the way to lock backdoors down, not only on the application, but on the network traffic would be to do whitelisting. But
That's a pain.
nobody's really ready for whitelisting.
I think I've only seen maybe 2 places that actually did it.
Yeah, I mean, if you want to get serious about it, whitelist your applications and whitelist your network.
You will need to know, the difference between maintenance hooks and backdoors. So just make sure you can tell the 2 apart.
Malware. So kind of the thing I've heard since like late 80s is viruses embed, worms spread. Right? That's how you tell the difference between the 2. Viruses are typically just going to. Then you've got multi-part type viruses. You got all kinds of different other viruses that break that convention, but in general, viruses embed, worms spread. A 0-day exploit, the official explanation or definition for that is the one you want to go with in the book. There's tons of definitions on the internet about what those really are, but it's really just malicious code where there's no fix. Or I'm sorry, an exploit for which there's no fix. So yeah, either there's no patch, no workaround. That would be a 0-day. Something that doesn't have a patch, but it does have a workaround, that wouldn't be a 0-day according to that definition. Or would it? Yeah, or fix.
Fix, yeah.
So viruses, macrovirus, still popular after all these years. Still see them. Office macro viruses, boot sector viruses. That's where I started my career. I haven't seen a boot sector virus in 25 years, probably. But I would assume it'd be hard to get it on your system. Stealth viruses, they all kind of stealth, unless they're just like ransomware. I guess that wouldn't be so stealth, would it?
Oh, it is in the beginning.
What's that?
So it is in the beginning.
It is in the beginning, right? Polymorphic viruses, just viruses that change, as they do what they're doing. Emotet, I think, is a real popular polymorphic virus. Multi-part date virus would be a virus that drops something and then does something else, and there's multiple parts, multiple things that it does. Those are the different types of viruses. Worms self-propagate, all sorts of damaging, cool things that they do. Now were you around for any of these? Like I love
Do I
you.
have to admit it?
Code
I'm
Red.
that old. Yes, I was.
Wasn't-
Yeah, for a lot of them.
Code Red was 1433, right? That was open to the internet. This is how it was back then. People just left 1433 open to the internet, right? So that's for 1433 is SQL, right? And that's how that spread. That hit hard. Melissa, I love you.
I remember. Oh, yeah,
Melissa
I remember
took
those.
down. So the way I think I get the names mixed up now, but the way Melissa spread was it would infect the system, and then it would look for email addresses on any text file on that system, and then compile and send out to that, send itself. That's how it would replicate. And so that would be all HTML files. That would be anything that's text readable. JASK software, PaintShop Pro, our software went out on every Dell. Remember they used to have prepackaged software on all these computers, right? So PaintShop Pro went out on every single Dell computer made, millions of computers. And so in one of the HTML help files of PaintShop Pro was support@jask.com. So as you went from like, I don't know, maybe 20,000 emails a day to 12 million emails a day like that. Holy crap. And there's no way to stop it. It just flood. Who's the email place? Crap.
Oh,
It starts with an M. Something lab, whatever. There's this new mail service where it was a distributed mail.
Message Labs.
Message Labs, there you go. Message Labs called, after I've been trying, our whole team been trying to fight this for like a week, right? Emails just like, we had like 37, something like that, servers stood up in front of our mail server, filtering email, looking for virus signatures. Still couldn't keep up with it. I mean, we were doing everything, right? Imagine like a week of not sleeping, just like, I don't know, try this too. And then Message Labs happened to call, and they didn't know that we were dying, and said it was like 60, no, it was super cheap. It was like $30 a user a year or something like that. You know, and they said, yeah, you know, we can, you know, filter through all your email and all that stuff. And I'm like, I don't know if you can do this much email. And they're like, well, how much is it? And I'm like, I don't know. I mean, there's store and forward, right? SMTV store and forward. So I haven't seen it all. I probably won't for like a year. I'm like, I don't know, 12 million, 13 million emails a day. I'm like, oh, that is a lot. Like, yeah, we'll take it. And I go, and it's going to be the same price? I said, yeah. All right. So where am I pointing my MX records again? You know, so and they had them in pods, right? They had them all throughout the country, pods of mail servers. And so, you know, we signed out. I couldn't sign fast enough and change our MX records. And then you started kind of seeing emails trickle in, but then they get on the phone with me like within like an hour. Like, holy crap, you just took down our pod in wherever. So we were taking down their mail. It was really cool. But they actually thanked us and gave us a discount, even though we were paying, because we helped them load test on accident. It was crazy. So that was one of my many worm
Yeah, we had one.
stories. Damn,
I want to say it was, I love you. It was the email, one of the email ones where
Oh, this one.
it was,
I love you.
I'm pretty sure it would, when that one ran, would it send out spam to everyone in your contacts?
Yeah, it was
That
yeah.
was it, right? That's what I thought. Yeah. Single exchange. I was the only admin. And
Well,
yeah,
that one had
it's like hundreds of thousands an hour. It's like, huh?
that one had an embarrassment factor to it, right?
Because you would hear it.
Well, that and I love you. It's like,
Yeah. We did.
Really?
We ended up turning off email,
yeah.
like shutting the server off.
And that one on the right, that's WannaCry. So now you take ransomware, you know, marry it to worms, and there you go. You ever seen WannaCry? Never? Okay. Yeah, we don't get many of those anymore, do we? When's the last time you got one? Oh, wow. We get others. Ryuk.
Oh my gosh, right?
Ryuk is the big one. Yes, hit Ryuk.
So, we just, dot, was it .888? Was it that one?
Trojans is like the old story, Trojan horse. They appear to be something. So usually it appears to be a legitimate program until you execute it, and then it does something. It plants a back door, it does something. That's what a Trojan is. Usually it comes in the form, used to always come in the form, not always, used to come in the form of games. Zeus is probably one of the most popular ones today. I think it's still out there. Actually, you'll still see back orifice out there, you know, floating around somewhere. It's crazy. They like never die. But yeah, Zeus Trojan, that was a banking Trojan. Crypto Locker is, I guess, a Trojan. NetBus, it's an older one, back orifice. But, you know, like the old story of, you know, Troy and Greece, you know, fighting their battle. That's the same concept, just applied to computers. Rootkits, so something that's been rooted is, a root is ring zero, right? The kernel's been compromised, or you're even below that, I guess. User mode, this is user mode, kernel mode. So user mode, a lot of viruses and things will play there, but if something's been rooted, the whole system's compromised. And start over. You know, basically, you don't know what you don't know. I mean, you had the entire system. I don't know what you've hidden where. We've seen domain controllers get rooted. The domain controller is rooted. Not only is it rebuild the server, rebuild the domain.
Just start crying.
Yeah, so, yeah, rootkits are bad. They're not very common, thankfully, but yeah, if you get rooted, you're done. Yeah, Anyway, antivirus software. So antivirus software is one of the things that we could use to try to combat some of this. Antivirus software, I don't know what the current stat is. Was it Virus Total? You guys ever been to Virus Total?
That's a good one.
Virus Total is a good place to kind of see what's going on with virus, because what people will do is submit their samples. And oftentimes they're viruses that the antivirus writers haven't seen.
It's TSA, it's the security theater.
Yeah, yeah. Well, and 30, I think it's, last I saw it was 33 days is about the average time it takes for something in the wild to get into an antivirus software, right? There's two types. There's the static signatures. That's the least amount of false positives, but it's also the slowest. And then there's the heuristic, which is looking for certain behaviors that happen in typical antivirus software. But there are other protections, other software like Carbon Black.
So that leads to a good question.
Bunch of other
What's the
ones.
difference between antivirus and endpoint protection? Antivirus is, it's mostly
One
marketing.
you can sell a lot more of
Yeah.
because it sounds cooler and people are buying it more.
I think part, well, an endpoint would be,
Oh, it's more holistic,
yeah,
right?
you're gonna have like DLP built in, web filtering built in,
Host
firewall.
Host-based intrusion
Yeah.
prevention.
It's multi-function.
Yeah,
Do you have to suck it in there?
yeah, I can't look at my picture.
And that's horrible.
But that is a good question. I mean, endpoint protection would be more holistic, protecting the whole endpoint, whereas antivirus would just be protecting against viruses.
So
And now
when-
everything's packaged, so you can't really just buy from the major vendors anyway, like McAfee, Symantec. I don't think they sell just antivirus software anymore. It's all kinds of other
You can
stuff.
still get that, but yeah.
And what is it, McAfee that tries to get me to install the Ask toolbar? Does that still happen?
Yeah, but it's
It was
almost,
them, wasn't it?
it's almost,
Jerks. I don't want the Ask toolbar. I wanted McAfee antivirus. Now I don't. Yeah, so anyway, antivirus.
so the other question, is Windows 10 Defender as effective as antivirus? They're all running 60 to 90 days behind,
They're all about the
30
same.
to 60, somewhere in there. But
The thing is, we have this, I think we try to pursue this thing to find software that's going to protect me against crappy behaviors.
Mhm.
And you're just never going to do it. I mean, maybe, I can't say never because you don't really know, but that's been the pursuit forever, is trying to protect users from.
You're
stupid
always going to be
behaviors.
behind. So
I haven't
All
said
I
that.
know, like play back now is that.
Yeah.
Go back and capture and, well, you blew it up, let's see what you did.
Mhm. Right. And who was, remember, there was a company, I can't remember, I don't even know if they're still in business, but one of their advertising ploys was, it was an anti-phishing software.
oh, there's
Remember that?
no, yes,
Did they-
sandboxes that people are using that.
No, I don't know if you're talking about the same thing, but,
No?
because they said, go ahead and click.
Yes,
That
no,
was
it's the
their
same
marketing.
thing.
Yeah. They're not in business anymore.
No, there's somebody else that does that.
No. Well, either
Or
way,
there's something similar.
yeah, somebody should rip them. Just don't go ahead and click,
Yeah. Proof point.
Oh, no, that wasn't proof point. That
No?
was-
They wouldn't do that.
No.
It's gotta be some.
There was some up and
There's-
coming startup,
Yeah.
because you saw it and then like you didn't see it anymore. So it was there
Gotta
for
be
a
one of
while.
the sandbox.
Yeah, it would open it in a,
Do you remember it?
I know what you're talking about. Somebody has something like that I saw, but yeah.
Yeah, ask Java how well the sandbox.
Yeah, right. Oh,
You
yeah.
can't get out of the sandbox. Server-side attacks, so server-side, client-side attacks, it's just where the attack is actually, it's the target. So server-side attacks would be the target, would be the server, client-side attack, client would be the target. And just, you need to know that for the exam, pretty simple. Web architecture attacks, so OWASP, you guys know OWASP, Open Web Application Security Project. There's a link, 2017, so the last one before that was 2013, so we were waiting for a while. But OWASP is kind of run by developers too, so it has some cred when you talk to developers about, security. These are the 2013 top 10 compared with the 2017 top 10. You don't need to memorize it. This is more for FYI for you. But it's good reference. we do reference OWASP quite a bit. Applets, Java, so the only two types of applets for the exam, Java and ActiveX. Java uses the sandbox, right? So you download, and it's actually a download, right? The applet gets downloaded and gets executed from your local system. Java relies on the sandbox for security. So the sandbox says you can do these things and nothing outside of this. ActiveX relies on a digital signature, right? A certificate to validate that this is actually one that's been published and vetted and whatever. So Java, object-oriented, bytecodes, it also requires your interpreter, right? It's not compiled code. Applets run in a sandbox, ActiveX. Similar in the way they work, but not really. They only work on Microsoft systems and rely on that certificate for validation. Both are attackable, various ways. XML and SOA. So SOA, a lot of time, it's more commonly kind of referred to as SOAP, and there's not really a super clear delineation between SOA and SOAP, the service-oriented architecture. I guess the P would be the protocol, the communication between. I underlined truly what XML is. It's just rules for encoding, right? How we're going to encode certain things. You've seen XML files before, parsed XML files, but you need to know the rules for decoding the XML in order to use it for anything. Usually those are somewhere in the XML file itself. Yep. They begin with the declaring some information about themselves, whatever. SOA is really just an architecture for communication with applications. Service to other components, communication protocol between the two. That's what the SOAP is. DCOM is distributed component object model, which allows Microsoft applications to communicate over the network. We're going to get to that again later when we talk about application development. Same with Corba. Corba is kind of the open source version of DCOM. But for now, knowing what these stand for and what they're sort of used for is fine, because we're going to come back to this again later too. So not a problem. Polyinstantiation, so multiple instance, right? Take the two words, poly and instance. In most cases, polyinstantiation. Now I changed, you see at the top, this is in reference to databases. So polyinstantiation would essentially make multiple copies or versions of the database that are connected with each other. And the purpose for doing that is we don't want to have an inference attack. So an inference attack would be I interrogate whatever the object, the database, for specific information, and I don't have access to the information that I really want, but I have access to information around it or about it potentially, so I can infer the information that I want from what I was able to gather with my access. That's an inference attack. So two different objects with the same name would be polyinstantiation. Make sense? So it'd be stored in multiple places, essentially. So it'd be difficult to infer because I'd be getting information from different places that doesn't necessarily relate to the instance I'm working with.
You can't create that table at that record because that exists already. Usernames potentially have multiple.
Yeah, exactly. I like that you're talking more this time. Last time you didn't talk anytime when I was talking. I like it.
You're going long.
Am I still?
No, you were last time.
No. Yeah, I'm trying not to. I'm trying to like keep on pace because I want to talk more and I'm fighting it. I want to explain more. I'm really fighting it today. So inference, deduction. So deduction, I don't have to have all of the possible things. The difference between inference and aggregation is aggregation, I know all the information. Or not all the information. I asked every single question that I could possibly answer. Like, for some reason, I think of Burp Suite here, like aggregation, like we try all different combinations of all different kinds of crazy data to see what we get back, but it's not the same application, but I just think of that. But aggregation would be, I ask every question possible, and I'll get the answer from that. Inference is, I ask things about the thing, it's like metadata, right? I ask about the data. And then if I get enough data about the data, I should know what the data is. That's what inference is. Make sense? Data mining and data analytics. So data mining usually requires, we use that term with, in relation to a data warehouse. So we're looking for patterns in data. And the example here is detecting fraud, like credit card transactions, right? You have a pool of, this is typical credit card transaction activity, right? Almost like a baseline. And so when we see deviations from that, that would be some sort of a red flag. I would use data mining to figure that stuff out. Data is really king. I mean, same with data science, right? If I don't have the data, there's no science, right? And so what you start with in data science is you start with the problem. You start with the question. What do I want to do? What do I want to solve for? And then go find the data, right? And all the while, I assume you're fighting confirmation bias because you may have an answer that in your mind of what the answer should be. So you're looking for data to back that up, but let the data tell you what's going on. Data doesn't lie. Well, I suppose it could. If you get an attacker in there manipulating the data, it's going to lie. Data analytics, so same sort of thing, very similar, but it doesn't necessarily need a data warehouse. I don't need a huge amount of data, but I do need enough for trends. I do need enough for some kind of a baseline so I can see deviations from that. Now, oftentimes you'll see things like this. We don't have to talk about AI now, but AI is usually making decisions based on different decision trees, and we'll talk about AI, won't we? Yeah, I'll leave it for that. Defense in depth, so gobstopper, not a Rollo, right? So most people build their networks, build their things with a crunchy shell GUI center. We're so focused on the perimeter, we forget about crap that are already in, or maybe they've always been in. So we want, and that's what I was showing you guys before, just when I was still working when it came, the NSA, I'm actually working in an adversary obstruction requirements assessment for a client right now. That's a really good document. I don't think most people implement it. I mean, if you actually read it, the document itself is pretty high level, but the references to other documents are like, yeah, I'm not going to get them to be able to do that. I mean, I can't even give you examples because it's so like kind of weird that I would do that with Active Directory. But anyway, segmentation, isolation, keep people compartmentalized. That's a big reason too why people don't have good data inventories, because they don't keep it in compartments, right? It's all over the place. So if you can get your hands around it, segment the network, and I hold like network guys accountable for this, we connect things, it works. Computers can talk, all right, we're good. We'll put a firewall up, see ya. Oh, you want it segmented, well, I'll throw some VLANs in. No, I'm not talking layer 3. I need a firewall here. So defense in depth is a strategy and it does work, but it requires work and I don't think people like to work. Mobile device defenses. So mobile devices, all kinds of products now, MDM was a big thing. It seems to have sort of fizzled out a little bit. Because truly, when you look at the risk of a mobile device, I mean, what are you going to get off of my iPhone anyway? Probably. You're going to get maybe access to email. Well, if people didn't use their email as a file server, they used it as an actual mail server, that probably wouldn't be that big of a deal. But you'll find files in there, right? You'll find confidential things that people have sent me. So, the risk is there. Whatever.
Generally, that means they've got OWA stuff anyway, so the risk is still there.
Right, with single factor authentication. Yeah, if I see, any of you have single factor authentication on anything externally exposed today? Because you're gonna get a talking to. Tired of it. And if you have RDP, with single factor authentication open, what are we gonna do? We get disqualified from getting swag at the end of the class. Yeah, we'll give swag out. Actually, yeah, people that make it through all the class, we'll give out some swag at the end. And we should do a pizza night too. You want to do pizza night on Wednesday, next Wednesday?
I did too. Sure. Rochester then.
Do you guys?
Both remote guys.
Oh, yeah, you guys,
You can send it and see if you want to.
I could order pizza there. I got the Domino's app.
I could deliver to my house, but you can try.
Yeah.
Just fly us back on.
Yeah. We should make this more fun because you guys are, I don't know, if I'm dry, it's probably me, isn't it? I need to have more exciting voice. It's me. I feel it. We should have more fun because security is fun. It's one of our principles. Have you seen our principles, our 10 principles for information security? Information security is supposed to be fun. So we'll make it more fun. I'll work on it. MDM, mobile device management, all kinds of software. It would be enforcing certain policies on mobile devices so that you can secure it. Enforcing things like authentication, remote wipe. You can enforce what applications can run, all kinds of good stuff. You can enforce wireless settings, so prevent you from connecting to certain wireless networks. I read an article recently that 50% or something of security people refuse to use public Wi-Fi. Yeah, but
50%.
right. But I'm thinking so what? I use a VPN when I connect to public Wi-Fi. It's not the end all be all, but I got work to do. So I still connect to public Wi-Fi, but I use VPN.
I use my tethering.
You have a favorite VPN app? Anybody? You use tethering? Yeah, because the cell network can't be compromised. I'm just kidding.
Don't use 5G.
If they're, yeah.
5G scared me. Yeah. But anyway, we can talk about this for a while. But if you have do you really not use public Wi-Fi? You don't use it with a VPN or anything?
Well, if I have to.
Really?
If I don't have service.
Really?
I get unlimited, or 10 gig of tethering. a
So I've
month,
seen so many security people use they say they don't use public Wi-Fi, but I've seen so many security people use public Wi-Fi.
I will use
without
it,
a
but
VPN.
it's not my first choice. Oh, yeah, but not without a VPN.
Yeah. Because if you have a favorite VPN app that you like to use, share it with people so that, because what would I be concerned about if I was using public Wi-Fi with a VPN? What would be my number one concern?
If what?
Threats to using public Wi-Fi with a VPN.
I think you'd still be on that network, you'd still be locally vulnerable to anybody around.
Yeah, but as soon as I set the tunnel,
Yeah, but if your device is if you have unpatched vulnerabilities, it could still hit your,
is that okay?
right? It could still hit your device.
Yeah. No, it's good discussion because, we should talk more about that because I think there's some good advice there that we can give people. If you are going to use public Wi-Fi, do these things. Make sure your devices are patched. Use VPN. Here's some good VPNs that you can use. Because everybody does it. All the business people, you see them all the time, and they're not using VPN.
Don't have it set to automatically reconnect.
Right, the automatic reconnect is a scary setting. Yeah, definitely turn that off because it only uses name, right, for authentication. Network access control, 802.1x. We'll talk about the 802 standards. Anything with an 802 is an IEEE standard, so it's a legitimate standard. 1x is about really it comes down to port access control, authentication sort of things. Authentication, remote wipe, encryption, those are all things I can enforce on mobile devices. Yay, that's Homer Simpson. Best day ever. Now for some encryption. And this is kind of fun. We got plenty of time. We're not going to get deep into encryption. We will on, not deep, we don't get deep, but Wednesday next week, we'll talk about specific encryption algorithms and how they work. We'll talk about hashing and stuff like that. But tonight, we'll kind of ease into that because we'll talk about some of the historic things about encryption and some basics. These are all terms that you'll want to know, and they do matter. So cryptology, anything with an ology on it is a science. It's a study of something. So that's the science of secure communications. Cryptography, it's just making something hidden from others. We don't have steganography up there, do we? So steganography is just is hiding the existence of a message altogether. Cryptography would be hiding what's in the message. You would still know that there's a message there, but you wouldn't be able to read it. So steganography is another thing,
Hiding a message in a picture.
Yeah. Yeah, I mean, if you don't even know there's a communication happening, then that's even better. Cryptanalysis, so analysis, this is breaking encryption or trying to reverse encryption, trying to look for a weakness in the the cryptographic algorithm or the key, something. What was the next one I have there? Cryptology again. Oh, the reason why it's here again is it's these two terms together, cryptography and cryptanalysis. So cryptography, making the message secret, cryptanalysis, trying to make it unsecret. Those two together is cryptology also. A cipher is just the algorithm, that's the math that makes encryption. Depending on the type of encryption, we'll talk about symmetric, asymmetric encryption, hashing. Those are the three that we're really going to talk about in the class. Plain text is just an unencrypted message. Ciphertext is the encrypted message. Encryption is converting plain text to ciphertext, and then decryption is going in reverse. Pretty basic stuff, but there's little nuances that you'll want to make sure you know, like cryptanalysis is the breaking of encryption. Sometimes we don't think of that very often, stuff like that. Collision, diffusion, substitution, and permutation. So these are the functions that all modern encryption algorithms are doing at some point. The latest is the latest standard encryption is AES. We'll talk more about that later, but that's I can never say the name right, Rindell algorithm. That's who created it. There was a whole competition that took place. Rindell, that's his. It is Rindell. But it uses these in its different states also. So confusion, basically just confusing the relationship between plain text and ciphertext. Diffusion is just spreading it out over a bunch of, over the message, right? That's another thing that takes place. Substitution is, we did these when we were kids, anagrams, is that the right thing? What's an anagram? Is that where an E is actually a C? Is that called an anagram? Do you know what I'm talking about?
I think anagram is where they
still have them in the newspaper? Do you guys read newspapers
Yeah, I
anymore?
have them in favor.
Yeah, where they.
That's an
rearrange the
anagram,
letters.
right?
Is the anagram, is where they take the word and then rearrange all the letters,
Yeah,
and you have to put them back in the correct order.
right, and that, yeah,
And that would be the anagram.
I think that's what I'm talking about here.
So now,
Substitution.
So binary could become brainy.
Well, like
That's an
a
anagram.
rot 3, a rotation 3, so an A becomes
Yeah.
D. That's a substitution.
Yeah.
All right, whatever. It's substituting letters. So throughout the encryption, this one letter may represent another letter, and so we
Always drink your
substitute
Ovaltine.
everything. Huh?
Yes.
What did he say? I didn't
Always
hear.
drink your Ovaltine.
Yeah, okay.
Christmas story?
Yeah.
He gets
Yeah.
the orphan Annie decoder ring.
Yeah,
Well, that's a code word.
Well, they would read off the,
but he had to decipher from the substitute the.
Oh, okay.
they would give out numbers or whatever.
Oh, yeah. I didn't have that movie in here. I have other movies in here that you guys need to watch in order to pass the
Oh, there's
test.
one.
Permutation, also called, it's another confusion. Just using, well, there's the
There's your
anagram.
anagram.
There you go.
You were on it.
I was. Substitution and permutation are often combined. The key in all of this is to destroy any likeness of patterns. So in the cryptanalysis, you can't find any pattern here, right? That would assist you in finding the plain text. Cryptographic strength, there's the Kirchhoff principle, which you'll have to know. The principle is that the strength of the encryption has nothing to do with the secrecy of the algorithm used for the encryption. So the most common algorithms that you're using today, like Rindell or Triple Des, if people are still using that, Two Fish, Hootie and the Blowfish, that's not really one. Did you know that? You're looking at me funny.
Just to hear what you're saying.
Are we still friends? Me and you, yes. See, he laughed. The Kirchhoff principle is, though, the secrecy of the key is what matters, not the secrecy of the encryption algorithm itself. The work factor is how much work it's going to take. So if I encrypt something that's maybe got a life value of, a year, and the work factor to decrypt it with the encryption algorithm I'm using is 10 years, that's good enough. That's what the work factor is. I don't think we think about that very much. So sometimes you'll hear about, in order to crack this encryption algorithm, it would take 700 billion years, or like, what, triple DES? No, not DES. Triple DES still hasn't been
Yeah,
broken.
no.
DES is 23, it's less than that, 12 hours.
Yeah, it's like less than a day.
Yeah. Triple DES, I don't think has been broken, but it's super slow. So everybody's using AES now, which is computationally infeasible to break. So the work factor for DES would be 12 hours. Right. Does that make sense? All right, so monoalphabetic and polyalphabetic ciphers. So a monoalphabetic cipher is really just a substitution cipher. It's susceptible to frequency analysis, so it doesn't destroy the pattern enough. But we would play with this when we were kids. The polyalphabetic makes it a little bit difficult. It uses one alphabet to encrypt, or one alphabet to encrypt, and then another alphabet to encrypt it again, right? It just goes through multiple rounds of encryption. That's what those are. The one on the left is I can't read it from here. Looks like a rotation 13.
Yeah.
And then the other one is that's a cipher disk. It's polyalphabetic. There's frequency analysis. So the most common letter in the English language is E. So if you have enough ciphertext, even without having to do all the work of like playing around with letters, you'd be able to tell, you'd be able to decrypt it pretty quickly if you had enough. You'll need to memorize this. This is one of the things that some people, this is one of the things that I did. I took my test in, like I said, a long time ago, but they gave us a pencil and a piece of paper because it was to fill in the holes. That's what you had to take the test. And this was one of the first things I actually put on the piece of paper and just drew this out, my exclusive OR. So the way it is if the two numbers are the same, it's going to be a 0 every time. If the two numbers are different, the bits, these are bits. When I'm saying numbers, they're bits. If 2 bits, so if I take 2 bits and compare them and they're not the same, it's going to be a 1. Right? And if you remember that, then you know the exclusive OR. It's still very much a basic function. They also call it a logic gate. It's very much a basic function of encryption even today. Right? So if you take an A and you break it into binary, that's what an A looks like, and you compare it and say your key is unicorn, so you're going to take the A and combine it with the U, you're going to use the exclusive OR, you end up with that, which is some other character, right? 20 in ASCII. So you'll need to know exclusive OR. It's still very much a basic function in encryption. Make sense? You have to memorize that. And you can play around with this. I mean there's nothing that, if you know that that's a logic gate, just take your own, take your name and, use money or something. Just use some random name or word as your key and encrypt your own. I mean, weird people like me do stuff like that with this. It's kind of cool. It forces you to kind of go through it. So some historic stuff. So cryptography has been around for like ever, I think. The hiding messages, certainly ever since we've been fighting battles and things like that. Egyptian hieroglyphics, they claim to be a form of encryption where they're using certain symbols to represent certain words, and there's still a bunch of hieroglyphics that they've never deciphered. People have dedicated their lives to deciphering some of the things the Egyptians used. The Spartan Sitel. So the Spartan Sitel, you'd wrap a piece of parchment paper or cloth around a pole, and then you write your message out on it. And you'd unwrap it and send it on its way. The key then to decrypt the message is the diameter of the pole. If I have a different diameter pole, it's not going to decrypt the right message. It seems pretty basic, but they used it in war. Just sort of cool. The Caesar cipher and rotation cipher. So Caesar had a rot 3 cipher, rot meaning rotation. So you rotate 3, and it's modulo. So modulo means it wraps around itself. So, if it's a Z, rotation 3, it becomes a C, right? That's the modular part. Yeah, and that's, so Rot 13 was used in a lot of bulletin board systems. Anybody ever been in a bulletin board system before? Gosh, I'm so freaking old now. I got my first copy of Windows 95 off of a bulletin board system, 26 floppy disks. I was the first kid in my, not kid, I wasn't even a kid anymore. I was 24. I was the first guy like that anybody knew that had it. Yeah, downloaded off a bulletin board system, 9600 baud.
Not far behind you.
Yeah, it's
Sadly.
crazy. But bulletin boards were really popular. Do people still use newsgroups? NNTP, is that still a thing that people use anymore?
Yeah,
Either?
we use it for BitTorrent too.
Oh, yes, okay,
Mhm.
that's where they went, yeah, I've heard that. All right, so anyway, rotation 13, that was Caesar. The Vignere cipher uses, I'll show you, it's a table of alphabets, right? So A through Z here, A through Z here, and where they intersect,
That's
that
your
would be
letter.
your letter, right? So it looks like that. That's a Vignere cipher. Those are rotation ciphers on the left. Still all susceptible to frequency analysis. So, you know, these are fun, I guess, if you have what would you do if you had like did you have a club when you were a kid?
Yeah.
Yeah, keep girls out and stuff. You'd do something like that back in the day.
I'm not that old.
No, cipher disk, you're not that old. Two concentric disks, so you'd rotate them, and the rotation, the offset would be the key. And a lot of this stuff isn't testable specifically, right? It's more giving you a background for encryption. So, but the cipher disk, Civil War, used for a long time. And that's a Civil War cipher disk on the top. I think things get a little more complicated. That's the Jefferson disks on the way top. 26 letters. So each one of these disks had letters, and then you turn them in offset and whatever. Created in the 1790s. I don't know if it was ever actually used. Book cipher and running cipher. So a book cipher is get this book, this page, this paragraph, this word, right? That's a book cipher. So you'd both have
Could
the
be-
same book.
Yeah, it'd just be like
You'd get the numbers.
3, 5, 4, page 3, paragraph 5, word 4.
Yeah.
And it would just be a block of numbers.
And the running key is the same sort of thing, but it's using letters instead of words, right? So, yeah, that's book cipher and running key cipher. Code books. Code books would be looking for code. They'd be like code words, like deer means soda, or something, code books. So you'd have a book with all these code words in it. The one-time pad is the only encryption algorithm that's been mathematically proven to not be compromised. There's no weakness in a one-time pad if you follow these three conditions. Number one, the characters on the pad are truly random. They weren't generated in some pattern. They were random pads. The pads were kept secure, and after you encrypted a message, you destroyed that pad. So you tear it off and you'd use the next thing, right? So if those three things are true, you can't break this. And this was actually really popular, back in the day. It probably still is now too, just in different functions and ways it's being used. The one-time pad, that's a machine. That's the Vernum cipher. This is the first time use. Gilbert Vernum, AT&T. This is kind of some of the stories around encryption. The best encryption book, if you're really into encryption, the best encryption book to get started with is Applied Cryptography. Have you ever, from Bruce Schneier? Really, really good book. Applied Cryptography. It's awesome. So Project Venona, this one was sort of, so Ethel and Julius Rosenberg, you remember they were spies? They were busted and they were using one-time pads to exchange communications. They made a mistake though, they reused pads. So had they not reused pads, the could potentially still be, not busted, but, it's people, it's always people. Just follow the rules, man.
OPSEC.
Yeah, just follow the rules. These are good movies. You ever seen any of these? Imitation Game, that's a sweet movie. So that's about Turing,
Mhm.
Alan Turing, who worked in Bletchley Park in World War II, played a huge role in helping with the Enigma machine. U-571, isn't that where they captured the Enigma machine?
I think so.
And then the Queen's Men was just sort of the role that women had played in cryptanalysis back then. All really good movies, and all pretty historically accurate, I think. Other machines, the Heber machines, these are rotor machines in purple. So a rotor would turn. As you type things on, the rotors would turn, and then that would be, what would come out would be your encrypted message, and then you type the same thing in, and what would come out would be your decrypted message. Used for a while, to the 1950s. There's Enigma. Enigma was the Germans' encryption machine. And actually, it was the Polish who started the cryptanalysis of that. People didn't give them a lot of credit for it because it was sort of finished off in Bletchley Park. But, it's cool because had we not captured and broken Enigma, some people say that the war would have gone on another 10, 15, 20 years. It was that valuable, being able to see your enemy's messages. You can debate how long, but Sagaba was our US one. Still never known to be broken. Looks like just a big, huge typewriter. I can only imagine how heavy that thing must have been. Because you remember, old typewriters are like heavy, right? They're made out of like some kind of cast iron something. Huge. But anyway, never been broken. That's what we were using. Purple. We've never seen, supposedly, never seen a working unit. Other than, when we captured, they were all broken. So a working unit. But it's like a phone switch. Instead of the rotors, it would be, they'd switch. So cool stuff. This will be on the test. So a lot of that other stuff, good. It's in the book. It's good information to know. Knowing the basics, some of it might help. But this is definitely going to be on the test. The Wassenaar Agreement.
Mhm.
So there was an agreement called COCOM, and COCOM was essentially, it protected commerce with countries that were not friendly to us. One of those things that sort of fit into that was encryption, the use of encryption algorithms. COCOM was replaced in 1996 with the Wassenaar Agreement. And so it has a lot of restrictions on trade and what have you, exportation, but also cryptography. So that's what the web page looks like. I don't know how actively it's really enforced, but you'll need to know for the test, the Wassenaar Agreement. That's it. I'm only 3 minutes late. So no class on Monday. It'll be a good time for everybody to catch up. You guys pretty much caught up in the reading? No? So this will be a good time. And truly stay on it. Read, get caught up, and come with questions. I work a lot better, and I think he does too, when we have questions rather than just sitting here talking all the time. Because I'm trying to read like what's going on in your mind and can I help?
Everybody's getting glassy eyed and nodding off.
So do come with questions. Brandon is going to send out the Slack channel, so we should have some good discussions there.
That could be a good place to pre-post questions that we can.
Yeah, because we'll both be on it and checking in every once in a while. Plus peers, other students asking and answering questions will be good. Pick it back up on Wednesday. This is where we left off on the book, page 160. So if you can, please read up to page 160 between now and next Wednesday. And that's it. Come with questions. So thanks, guys. Have a good night. Planning it for